Excellent. So this is the fourth day of an excellent conference, and we have had presentations on each of the days about linked art. So for this, I will try not to simply repeat the things we've already said, but to sort of summarize how it fits in a bigger picture, and sort of why we're doing what we're doing. So for folks who have not been part of the previous linked art sessions, what is linked art? And it's a linked, open, usable data profile with the emphasis here on the added usable or usability, which is collaboratively designed to work across cultural heritage organizations, easy to publish, and enables a variety of applications. So we have some design principles that we follow. We are focused on usability, and hence we put it right up front in that definition, rather than on 100% precision or completeness. So we would rather have data that's usable than data that's perfect but not usable, because if it's not usable, it won't be used. If it's not used, we've all wasted our time in publishing it. That consistently solves actual challenges from real data. So this one's also important. The consistency means that once there is an implementation of something, that we can use that same implementation across different organizations. And solving actual challenges rather than theoretical ones is important, because if it's just solving theoretical problems, well, that doesn't really help anyone. So we want to be able to make an actual difference in the world rather than just theorize about the world, and from real data. And that's also important, because if we don't have the data to support the solution to the challenge, then we're not going to solve it. So there's no point having a perfect theoretical model with no data that is capable of being filled into the slots in the model. We develop linked art iteratively as new use cases are found. So we go back and we reassess how, with this new knowledge from a new use case, would we solve this consistently with all of the other patterns that have come before. And we don't want to solve the world. We want to solve sort of the easiest 90% of the use cases, but only using 10% of the effort, because particularly this year, we only have 10% of the effort in order to make progress. So I think there's three sort of sections of requirements for success, really in any standard, but especially for linked art, which are shared abstractions, sustainable implementations leading to satisfied audiences. And I gave a keynote at CNI earlier this year, where I talked through all of these things, which you're welcome to look at. But very briefly, for the shared abstractions, we use CRM as our underlying conceptual model, and the CRM ontology plus extensions and linked art extensions for the ontology. We use AAT primarily for vocabulary. The linked art is the green part in the middle. So we try to then specialize. We select parts of those models, ontologies, and vocabularies for use, implement them in an API to then serve various audiences, from humans to machines to the network to research audiences. We'll talk about those in turn. So the conceptual model from 50,000 feet is relatively straightforward. And if you've been to CIDOCs in the past, which most of you have, I'm sure, you will have seen slides like this many times. So in the middle, we have an activity. It then has what, when, how, who, and where. So what is the activity on, which is either a physical or intellectual object? When did the activity occur? How did it happen? Who did it? And where did it take place? And then we simply slot in the information that we have into this model. So the profile then selects methodologies and patterns and classes and properties to use. And this, don't try to understand it if you weren't part of the session, but this is a mapping that we did yesterday of a statue of Venus that was found in 2 different parts in different places by different organizations, and then brought back together. This is the sort of the object focus with names, identifiers, productions. The discoveries came in a different part of the model. So then the API is a selection of technologies, and we selected essentially JSON LD, which is a relatively new, as you can see. The 1.1 version was published this year in July. So it's a relatively new spec for publishing RDF and linked open data as JSON, which then helps to bring in that usability for the software engineering and implementations. So on the left, you see an example of how dimensions are maximally described. Not all of those features are necessary, but I think without too much difficulty, you can see it's about an object which has a dimension, which is classified as height. It's got a value, but it could be between 22 and 26. It's in inches. It's got a name which is used for display, and that name is 24 inches high, plus or minus 2 inches. Which then, so this really exemplifies one of our core patterns, which I'll get to in a second, of enhancing from a string that a human can understand, but a machine cannot, through to structured data that machines can understand and do things with. APIs also need to take into account the interaction between systems, and for that we use the web, of course, the world's largest and greatest information system, meaning, of course, we use HTTP. We follow REST principles. Things have identifiers. When you dereference that identifier, you get the thing, as opposed to a service-oriented architecture. So this progressive enhancement principle is something that we think is also important because it provides on-ramps and lowers the barrier to entry for new implementers, meaning that we get better adoption than something that starts off hard and just gets worse. So at the beginning, there is data for humans, which is mostly strings. So there are separate entities with attached textual descriptions, names, and identifiers, but nothing that machines could really compare. So this is data that would promote a collection interface on the web for people to look at, but not for any sort of comparison. But we can start there and then enhance it as time and resources allow to data for machines, where we add structure. So this is the same entities with the same descriptions, but also adding in machine processable and comparable values. So think of dimensions. A machine is not going to be able to compare the string 24 inches high, parentheses, plus / minus 2 inches, but it certainly can compare value of 2, unit of inches, value of 22, unit of inches, and type of height. Then we can go to data for the network, or distributed, to follow the STRA pattern, where entities are connected across systems and then across institutions. This gives us greater insight into the ecosystem and the shared cultural heritage that we all participate in. Then finally, data for research, where the data needs to be more stringently assessed. We need sufficient accuracy and sufficient comprehensiveness in order to answer the research questions once we've been able to aggregate the data together from across those different systems and institutions. And as we'll see with Michael's presentation, I'm sure you can get a long way through this with not that much effort. So one of the other questions that has come up over the week has been about implementation strategies and how to take a data source and then get into building linked art. So at a high level, there's five steps. First, you need to understand your data, what it means, and how it would link in with the linked art model. I think the easiest way to do this is to bring your data to one of our bi-weekly mapping calls, and we can help you to do that. Of course, the on your own way is to read the documentation, look through the use cases and the modeling work, look at the APIs and so forth. So once you understand what your data is, of course, you need to get it out of the existing system, which of course is system dependent. We can't really provide that much advice on how to use your collection management system because all collection management systems are different. However, normally this is quite straightforward. If it's not, then you might consider another collection management system. Step 3 would be to transform it, and this is the hard part. So a couple of things that we are looking at building in the coming year, which Kevin might be able to speak to, would be taking a formally structured CSV document and then turning that into linked Dart, and taking Lido, probably Lido 1.1, which we've heard about over the last week, and turning that into linked Dart as well. However, to do it from scratch, probably you'll need some sort of software engineering or software development capacity, either in-house or as a consultant, to really do it well and get all of the information out of the collection management system or other source and into linked Dart. Step 4 would be to validate that the transformation has been done successfully, properly. We know that this is a very necessary step, and we will be building a validator over the coming year as well. And then finally, the easy last step is to publish it. So linked Dart as linked open data is part of the web, rather than just simply being something that sits by itself. So really all that needs to be done is to put the resulting JSON files onto a web server, and that's it. There's no need to have complicated search algorithms or anything like that. Just put it online and people will be able to use it. So 12 minutes, not too bad. Thank you. That is our pretty easy to remember URL. And please do come and participate, which I think Manuel is going to talk about now.
Yes, thank you, Rob.